What if I told you teleportation is already real? Not in the way sci-fi shows people dissolving into blue light and reappearing somewhere else, but in laboratories around the world, scientists are teleporting particles across cities, and even into space. It's called quantum teleportation, and it's one of the strangest, most mind-bending phenomena in physics. But how does it work? Could it ever be used to teleport an object or even a human being? And if it were possible, would the you that arrives on the other side actually be you? To answer that, we have to dive into quantum physics, cutting-edge experiments, and some of the strangest paradoxes about what it even means to exist. Teleportation works because of a phenomenon called entanglement. Imagine flipping two coins that are somehow linked. If one lands heads, the other instantly lands tails, even if they're on opposite sides of the universe. That's entanglement, particles that share a quantum state. They don't just influence each other, in a sense, they are each other across space. Einstein hated this idea. He called it spooky action at a distance because it seemed like information was moving faster than the speed of light. But experiments over the last few decades proved Einstein was wrong. Entanglement is real, and it defies our everyday logic. For decades, physicists argued over whether entanglement was real or just a flaw in quantum theory. But then came Bell's theorem and experiments in the 1980s that confirmed it beyond doubt. Bell's theorem proved that no classical, hidden variable explanation can reproduce the predictions of quantum mechanics. Experiments showed the quantum view is correct. The universe really is spooky. So, how do you teleport something using entanglement? Let's set up three particles. Particle A, the one you want to teleport, particle B, and particle C, these are entangled. You keep particle B with you, and particle C is far away, maybe in another lab, another city, or even on a satellite orbiting Earth. Here's the trick. You perform a special measurement on A and B. That measurement destroys A, but it also instantly forces C to take on the exact quantum state A used to have. In other words, the essence of A has been transferred to C, no matter how far away it is. This isn't theory. It's been done. In 1997, the very first quantum teleportation experiment was successful. And in 2017, Chinese scientists teleported the state of a photon from the ground to a satellite over 1,400 kilometers away. That's not science fiction. That's happening right now. Now, for the wild question, could we use this to teleport you? Here's the problem. Your body contains about 10 to the power of 28 atoms. That's 10 million trillion trillion. To teleport you, we'd have to measure the state of every atom, transmit all that data across space, reconstruct you atom by atom on the other side. The data alone would be astronomical. It would take more information than is stored in all the computers on Earth, multiplied billions of times. But there's an even bigger problem. In teleportation, the original particle is destroyed, so if we teleported you, the you standing here would be gone, and a perfect copy would appear somewhere else. That raises a terrifying question. Would that still be you? Or just a clone that thinks it's you while the original consciousness was erased? Teleportation isn't just a physics problem, and it brings us to one of the deepest paradoxes in philosophy, the problem of identity. So let's think bigger. If we can teleport information perfectly, could we eventually teleport matter itself? Could we one day teleport an apple, or a chair, or maybe even you? It sounds impossible, but so did flying, landing on the moon, or splitting the atom, until suddenly it wasn't. And then there's the deeper question. What does teleportation say about reality itself? Are we just information patterns that can be copied and moved? If so, what does that mean for consciousness, identity, even the idea of a soul? Let's say we solve the technology problem. You step into a teleporter, there's a flash, and suddenly you appear on Mars. But did you actually travel there? Or did the machine kill you, atom by atom, and build a copy on the other end? Philosophers call this the teleportation paradox. If the teleported version has your exact memories, personality, even your sense of self, are they really you? Or just a duplicate who thinks they are? If you believe consciousness is purely physical, a pattern of atoms and information, then teleportation is survival. You've just been moved. But if you believe consciousness has something irreducible, a soul, or a unique stream of experience, then teleportation is death. The original you is gone, replaced by an imposter. Here's the creepy part. From the outside, no one could ever tell the difference, not even the copy, you, because they'd insist with absolute certainty that they're the real you. Would you step into the machine knowing that? This is where physics bleeds into philosophy and even psychology. Teleportation isn't just about moving matter. It forces us to ask, what does it mean to be? But here's another way to think about it. Every night when you fall asleep, your consciousness disappears. Hours pass. Then suddenly you wake up. From your perspective, it feels like you simply continued. But what if the you that wakes up is not the same conscious stream as the one who fell asleep? In that case, you're already living through a kind of teleportation paradox every night. The person who opens their eyes in the morning has your memories, your personality, your sense of self. But is it really the same you? Or just a perfect copy that thinks it's you? Most of us don't question this because we experience continuity. But teleportation forces us to confront that uncomfortable idea directly. How do you know the you that wakes up is truly the same as the one that fell asleep? This paradox has cousins in philosophy. The ship of Theseus. If every plank of a ship is replaced over time, is it still the same ship? Your body already does this. Most of your atoms are replaced every 7 to 10 years. Are you still you? Cloning thought experiment. If we made a perfect clone of you right now, down to every memory, which one is the real you? Consciousness split. If a teleporter accidentally creates 2 of you, who is the original? Teleportation doesn't just challenge physics. It challenges our very definition of identity. And it suggests something wild. Maybe the self is less about the atoms we're made of and more about the information pattern they hold. So if we can't beam Captain Kirk yet, what can teleportation actually do for us? The answer is a lot. Quantum teleportation is the foundation for a future quantum internet. A communication network built on entanglement would be completely unhackable because any attempt to eavesdrop would instantly break the quantum state. It could also connect quantum computers across the world into one massive machine, solving problems that today's supercomputers could never touch. So even if we never teleport a person, quantum teleportation might still reshape our entire technological world. So teleportation is real, but right now it belongs to particles, not people. Still, every photon that teleports across space is a reminder. The universe is stranger than we can imagine. And maybe the real question isn't, can we teleport matter? But what does teleportation reveal about who we are? This is Mind in Motion. If you enjoyed this journey, subscribe, because the physics of the future is only getting weirder.